Dear 9th standard students, today's topic is in chapter Pressure and Fluids is mathematical expression for pressure in fluids. Mathematical expression for pressure in fluids. Here one diagram is given, try to understand that, then I'll tell you how to solve it. See, one vessel is given in which some kind of liquid is there which have density rho, R-H-O, rho. This is not P, it is rho. Rho is written like this, okay? And consider this liquid, and in this liquid just assume there is one cylinder which have the same length or depth as that of liquid in the vessel. Depth is H, and area of cross section, this imaginary cylinder is A. Area of cross section, this circular part, area of this part, this or that, same only, 1. And rho is the density of the liquid. This is the situation which we can use to derive pressure. And we know what is pressure. Pressure is force divided by area, or weight. Weight and force one and the same thing. Weight divided by area. And we know weight is having a formula mg divided by area. And we know m have a formula. We know density is equal to mass by volume, and cross multiply mass is equal to volume into density. So mass is volume into density into G as it is, divided by A. And what is V? Rho and G are constant at a place for a liquid and place. What is V? V is equal to area of cross section into length or height. Right? So if we put these values, ultimately what we get? Pressure. So we have to start from here. We have to find the volume of the liquid in that imaginary cylinder. Right? Volume of the liquid. So we'll start from volume. After getting volume, we put it here. Volume into density, we'll get mass. And after writing mass in this formula mg, we get weight. Weight means force only, and force per unit area give us pressure. So this is our workout. So we have to start from volume. Then we calculate mass. Then we calculate weight. Then we calculate pressure. Right? So same way it is done here. Volume of imaginary column of liquid, this imaginary column of liquid, this one, imaginary one, is area of cross section A into length. What is area of cross section? A small a, length is height of that imaginary cylinder H. A into H, this is volume. And what is mass? What is mass? Mass is equal to volume into density. Volume into density. So what is volume? A into H. In place of V, we'll write A into H, and density rho as it is. So we'll get mass. Right? Volume into density. Density is rho. And what is volume? It is A into H. So A into H into rho is mass. And we multiply mass with G, mg. That is weight of the liquid. What is mass now? AH rho G. And into AH rho, this is mass. Into G, it becomes weight. And what is pressure? Thrust exerted by liquid on the base of the beaker is, okay, that is force only, weight only. What is the thrust exerted by liquid on the base of the beaker? It is equal to weight of the liquid, and weight of the liquid we have already calculated, AH rho G. And what is pressure? It is thrust by area or force by area. right? and force is AH rho G divided by A small a cancelled, and what we get, P is equal to H rho G. Clear? So this is the way we can calculate the formula for pressure in fluids. Now next topic is next topic is factors on which the pressure at a point in a liquid depends. And three factors are given in this formula itself. First one, pressure is directly proportional to depth. Pressure of a fluid is directly proportional to its height or depth. First factor. More the depth of the liquid, more is the pressure. Less the depth of the liquid, less is the pressure. Second factor is density. Pressure of a fluid is directly proportional to its density. Means more the density of the fluid or liquid, more is the pressure. Or lesser the density means lesser is the pressure. So two factors. Then next factor is pressure in a fluid is directly proportional to acceleration due to gravity, G. More the value of G at a place, more is its pressure. Means if we take same liquid on earth and same liquid, height of the liquid in the same vessel on moon, then where the pressure will be more on earth, because acceleration due to gravity on earth is more. Therefore pressure is more. Or if we take same height of the liquid at equator and the same height of the liquid, same liquid also at poles, where pressure will be more at poles. Why? Because at poles acceleration due to gravity is more. But at a place G is same, so it will not affect pressure. Pressure of a fluid is independent of area of cross section. See, in this formula for fluid pressure H rho G, there is no letter which indicate area of cross section. So means pressure does not depend on area of cross section, independent. Right? And fifth one is if Pa is pressure due to atmosphere, then total pressure at a point within the liquid is Pa plus H rho G. Try to understand this. I'll tell you. Suppose here we have a liquid. We have a liquid in this vessel. And we want to find the pressure at the bottom or anywhere. Now pressure here is because of liquid also, liquid pressure, and because of atmosphere also, that is atmospheric pressure. Both pressures are acting here. So what is the total pressure at the bottom of the liquid or inside the liquid? It is atmospheric pressure plus pressure due to height of the liquid. If H is the height, pressure due to height of the liquid, H rho G. So what is the total pressure in a liquid? Pressure due to depth of the liquid at that place plus pressure due to atmosphere. So this is the fifth factor on which pressure depends. Right. Now next is laws of liquid pressure. Next topic is laws of liquid pressure. Following are the laws of liquid pressure. First, almost same little change. Pressure at a point inside the liquid increases with depth. Already we have done P is equal to H rho G. More H, more the depth, more is the pressure. Clear? So that is already done. Then second is pressure at a point inside a liquid at a given depth increases with increase in density of the liquid. This also we have done. P is equal to H rho. Rho means density. More the density of the liquid, more is the pressure. So if in place of water you take mercury, mercury have more density. Therefore pressure exerted by mercury for the same depth will be more. Pressure is same in all direction about a given point within the liquid. P is equal to H rho G. Right? So if you take a point, say this point in a liquid, then for this point in any direction, for this point, height is same, H is same, density of the liquid is same, G at a place is same. So all the points are same. So therefore pressure at a given point in the liquid is same in all direction. Only direction changes, but pressure will remain same in all direction. This is the third law. Fourth one, pressure is same at all points in a horizontal plane at a given depth in a stationary liquid. Suppose there is a stationary liquid. I will show you. Suppose this is a stationary liquid, means liquid is not moving, right? And this is a liquid, and in under the level of the liquid here there is a horizontal line. On this horizontal line, pressure everywhere on this horizontal line is same. Why? Because on a horizontal line, depth at all the places is same, so H is same. And because it is same liquid, rho, density of the liquid is same, G at a place is same, and therefore pressure is same. Because pressure depends on these three factors, and all these three factors are same for all the points on a horizontal line. And if these three factors are same for all the points on horizontal line, that means pressure on all the points will be same only, right? So this is the fourth one. Now come to the fifth one. Liquid seeks its own level. This you can understand from this diagram. See, this is a special kind of diagram. 5 vessels are there. In all these 5 vessels, their bottoms are connected. If you put liquid in one vessel, you will see the level of liquid in all the vessels will be same. It cannot be like this. Here level is more, here less, here more, here less, here more. No. Level, okay, means the height of the liquid in all the vessels will be same only, provided they are interconnected at the bottom. So even if in the beginning, suppose you put you put one lid, means a block the liquid, you fill it up to the top. Liquid will be at high level. In this side no liquid, but when you open this, all will have liquid up to the same height. It means liquid seeks its own level, right? Dear students, before we discuss this topic of experiments to prove laws of liquid pressure, before that we'll discuss this topic on page number 94, gas manometer. What is gas manometer? It's a device for the measurement of pressure of a gas. This is definition. Device for the measurement of pressure of gas. Also we call it pressure gauge. When pressure of a gas is measured is higher or lower or nearly equal to atmospheric pressure, okay, then this instrument is used just to find out whether the pressure is more than atmospheric pressure, less than atmospheric pressure, or equal to atmospheric pressure. We use this gadget. What does this gadget consist of? It's very simple gadget. It consists of U-shaped tube. Some side is longer, smaller, that happens, but U-shaped tube is there. And in this U-shaped tube is attached on a wooden board. I'll show you. See, here it is attached on a wooden board. Wooden board is there at the back side, on which graduation marks are there, means readings are there, right? And inside colored water is added. Colored water. Why colored water? Because you can see the level of water very easily in the glass tube if it is colored. And normal cases, what is the pressure acting on this side of water? Atmospheric pressure, because this is in contact with air. If this side also atmospheric pressure is acting, right, this limb A is not connected with any gas, means here also air pressure, here also air pressure, atmospheric pressure. So both the pressures are equal. Therefore level of the liquid in both limbs, both sides will be same. But if this A limb is connected with the help of rubber tube, is connected to some gas, and suppose that gas have more pressure than atmospheric pressure, So this gas will push the level of liquid in A down. If this level in A goes down, then the level of liquid in B goes up. It will be like this. In A, level comes down, and B, it goes up. And if you measure the difference in height of liquid in both the limbs, that will be H. Okay, up to here, from here to here, that is difference of height H. Now, what are the pressure on the acting on A limb? On A limb, there is just one pressure, that is pressure of the gas. What is that? P1, that is pressure of the gas on the left limb. But what is the pressure on the right side limb, B limb? Two pressures are there. One, atmospheric pressure is acting. Atmospheric pressure is acting on the surface of liquid, plus pressure due to H height of the liquid. What is H? It is the difference in height of liquid, water or any other liquid in both the limbs. So two pressures are acting here. P, atmospheric pressure, plus H rho g. Normally we write P as PA, A for atmospheric pressure, plus H rho g. So this will be the pressure of the gas when that gas have more pressure than atmospheric pressure. And what is H here? The difference in height. What is rho there? Density of water, if you have taken water. G, acceleration due to gravity. If in another case, if gas have less pressure than atmospheric pressure, so gas have less pressure but atmospheric pressure is more, therefore the pressure in B limb is more, therefore level in B limb comes down and in A limb it goes up. Now what is the pressure in A limb? It is gas pressure plus pressure due to this H height. Two pressures are there on the left side. And what is the pressure on the right side? Atmospheric pressure, PA. Now how will you get P1? That is pressure of the liquid. P1 is equal to what? PA, atmospheric pressure, and plus H rho g. If it is transposed to other side, it is minus H rho g. So atmospheric pressure minus pressure due to that height of the liquid, which is actually the difference between the height of liquid in both limbs, right? So if pressure is more, pressure of gas is more, then atmospheric pressure plus H rho g. What is H? Difference in height of the liquid in both limbs, plus H rho g. If pressure of the gas is less, then atmospheric pressure minus H rho g. This way we will get air pressure or gas pressure, right? Because the need, this manometer is required in the earlier topic, this topic, so that is why I have discussed it. Now come to the next topic. Experiment to prove the laws of liquid pressure. These are the laws which we have already discussed. So what is the arrangement? Try to understand first of all the arrangement here, right? What is the arrangement? One manometer is there. Manometer is there in which water-colored water is taken, right? And graduations are also there. So we can easily take the difference in height by using these graduations. A limb is connected with this rubber tube. This is a very long rubber tube, right? And on the other end of this, here one end of the rubber tube is connected with A limb, other end is connected with the inverted funnel. So this is the rubber tubing, and here inverted funnel is connected. Inverted funnel is connected like this. Inverted funnel is connected, and on the brim, this mouth of the inverted funnel, one rubber piece is attached. It is tied on the mouth of the funnel. Rubber balloon piece is taken and is tied on all the sides. Airtight tying is done on this side. Means the water cannot go inside because rubber balloon is placed on the mouth. Say this is the mouth, and on this rubber balloon is tied nicely, right? So this is what they are showing here. This one. This is the arrangement, and this arrangement is explained here in this first paragraph. Clear? So you go through this paragraph. Now we have to prove the first law. What is the first law? more the depth of the liquid. See, this is the first law. Pressure at a point inside the liquid increases with depth. Means more the depth of the liquid, more is the pressure. Less the depth of the liquid, less is the pressure. Right? Now what is done? Suppose this funnel is kept at some. This is when one vessel is taken, very deep vessel is taken, depth is more, and liquid is taken in it, say water. And we keep this funnel up to say 10 centimeter depth. From top to the bottom, depth is 10 centimeter. And accordingly, because this side pressure will be more. Why? Pressure due to atmosphere and due to the depth. Two pressures are this side, so pressure will be more. So therefore, the level of liquid in A limb comes down and B limb goes up. The difference in level in both cases, both limbs, this difference in level will be the measure of the pressure due to this depth of the liquid. Means whatever pressure is applied by 10 centimeter depth of the liquid, same will be shown here. Right? So the difference in the level of liquid in both the limbs is the measure of pressure of the liquid in the vessel. Now what we do? We increase the depth from 10 centimeter to say 20 centimeter. So if depth is more, then immediately we'll see here also the level of liquid in B limb rises and A limb comes down. So this difference in level will be more. More the difference in level, more is the liquid pressure. Means if depth is more, and this manometer shows that pressure is also more in A limb, and that pressure in A limb is because of the depth only. Do you understand? So this first experiment proves that if we increase the depth of this funnel, with that pressure acting on the funnel upward on the balloon of the funnel also increases. Clear? So first law is proved. If you decrease the depth to 5 centimeter, then pressure will decrease. So the difference in level of liquid in both the limbs will be even lesser. Then pressure will be less. So it proves that pressure in a liquid depends on its depth. More the depth of the liquid, more is the pressure. Second law is to prove that pressure at a point inside the liquid increases with increase in density of the liquid. Now you do one thing. See, in one case you take water, right? Same amount of water in the vessel you can take. And in second case you do one thing, take mercury. But in water also depth should be kept same 10 centimeter. In mercury also it is kept same 10 centimeter. Right? So one factor, that is depth, will be same in case of water when it is taken here in the vessel, and in case of mercury also depth will be same 10 centimeter, and place is same. Therefore out of two factors which affect pressure, what are they? H rho g. H is same, g at a place is same, they are constant. So now if pressure changes, it will be because of density only. Right? So what is done? First water is taken and we note the difference in the level of liquid. It will be less. But if you replace this water with mercury, but depth 10 centimeter only. Right? Then what we find, because density of mercury is more, so what we find, the difference in level of liquid in the limb will be more. It means that if liquid is denser, have more density, then pressure applied by that liquid also will be more. And if the liquid have less density like that of water, then pressure applied by the liquid also will be less. It means pressure applied by the liquid at a given depth is proportional to density of the liquid. More the density, more is the pressure applied. Right? Now third law is pressure is same in all direction about a given point within the liquid. Third one. And fourth one is pressure is same at all points in a horizontal plane at a given depth in a stationary liquid. So this thing is proved by this second one, third one. See, In this case, depth is 10 centimeter. Here also it is 10 centimeter. Here also 10 centimeter. Here also it is 10 centimeter. Got it? So depth is same, density is same, G at a place is same. So pressure acting in the upward direction is same here. Upward. Why? Because the balloon is upward. So pressure by the liquid is applied on the balloon only, which will be transmitted up to here. Right? So in the upward direction it is same. Now we come to this diagram. Here the funnel is pointing towards left side. But the depth is same 10 centimeter. Depth is kept same. 5 centimeter, half part of the funnel below, half above. That means center of the funnel is at 10 centimeter only. So in this case also pressure is applied now towards right side, because this funnel is facing left side, pressure is applied in opposite direction, that is right side. And that also will be same. If you check the level of liquid in both the limbs, it will be same. That means pressure when the funnel is facing downward means pressure is acting upward, and when the pressure is acting right side will be same only. Means pressure at 10 centimeter towards upward direction and towards right side direction is same. If you change the mouth of the funnel to the right side now, then pressure will be acting towards left side, then again it will be same. Or if you do it like this, see this liquid is same, but take the tubing like this, and a funnel is kept upward like this, but at same height 10 centimeter. Now in this case pressure will be acting downward. But because depth of the liquid is same at which this surface of the funnel is kept, the end of the funnel is kept, therefore pressure will be same. Means pressure acting upward, downward, left side, right side, in all direction means will be same, provided the depth is not changing, liquid is not changing, place is not changing. Do you understand? So pressure at a given depth in all direction is same. Same way, if you keep, say this is a vessel in which you are keeping funnel, you keep funnel here, you keep funnel here, you keep funnel here or here or here, at all points. At all these points depth will be same. Density of a liquid, same liquid will be same only. Acceleration due to gravity is same. All the factors H, rho, G are same. So pressure on the same horizontal line at a given depth we can't change. Depth is given, will be same. Pressure will be same if provided the depth is same. Right? So this fourth law also will be proved by this method. Then last one, that is liquid seeks its own level, cannot be proved by this arrangement. It is proved by this arrangement only. Already we have done this. Right? If you fill liquid in any vessel, their shapes are different, sizes are different. Means whatever are the sizes, what level of liquid in all the vessels will be same, provided they are interconnected at the bottom. So this activity proves that water seeks its own level. Water seeks its own level. And this activity is used up to supply water in cities. See how water is supplied in cities. I'll show you. Just try to understand nicely. What is there? Suppose, in the nearby vicinity of our locality, overhead water tanks are there. Overhead water tanks are there. And they are connected with pipes somewhere. Say this is a pipe. And these pipes are underground pipes. Big pipes are there, underground pipes only. And these pipes are reaching near to our place. And from these pipes, small pipes are taken, connected with it, which are coming to our house. And suppose our house is this one. 2-3 floors are there. Right? Now this pipe will reach our house and reach anywhere. The tap can be on the first floor also, on the second floor also, third floor also, any floor. Tap can be at any floor. Clear? Now how the water reaches or to the top floor or reaches the ground floor or first floor or second floor or any floor? How it reaches there? See, water in the overhead water tank is level of water is very high, very high level. And these vessels, this is a vessel, all these vessels, this tanker and these taps and pipes, small pipes, they are interconnected. See, these are vessels only. And all these vessels are connected at the bottom. Right? So when this tap is open, so water try to seek its level. Means which level? Water in the tap, in the pipes of the tap, try to seek this level. So it try to reach there. Because this is law, water seeks its own level. So the water in the pipe try to reach that height. Which height? That height which is there in the overhead water tank. But in trying to reach there, it rises up. And if this tap is open, water will come out. Now water cannot go there because vessel, pipe is not there. If pipe you provide up to there, water will reach there also. But because tap is open, no pipe is there, so what water can do? It will come out of the tap. So by using this principle that water liquid seeks its own level, we are supplying water in big cities through overhead tanks. Now we'll discuss consequences of liquid pressure. Simple daily life examples. First one, why is the wall of a dam made thicker at the bottom? If you have seen dams, dams are like this. Like this. Here water is there at the back side of the dam. So why dams are made thicker? This is the wall of the dam. Back side water is there. Water is there. Water reservoir. So why at the bottom? Here bottom, the wall of the dam is very thick. On the top it is not that thick. Bottom it is very thick. Why? Because see, at the bottom height of the liquid is very large. Because height of the liquid is more, so therefore pressure at the bottom of the dam is very, pressure of water. Okay, acting on the wall of the dam is very large because H is very large. Right? To bear that high pressure, that wall also has to be very strong and broad. That is why at the bottom of the dam wall is made thicker. Thicker in a way means stronger also. As we know that liquid pressure increases with depth, at the bottom of the dam liquid pressure is maximum, so maximum pressure is applied at the bottom of the dam. A strong thicker wall is required to protect the dam from maximum liquid pressure, so that dam wall is made thicker and stronger just to protect it from collapse. This one. First, second reason question is, why do divers use special protective suits for diving in a sea? When sea divers go in depth of a sea, goes down into the water, depth of water increases. With that, and we know that pressure is equal to H rho G. So H means depth increases. With that, pressure also increases. Total liquid pressure is much more than the blood pressure. You know, our blood pressure is slightly more than atmospheric pressure. Pressure of our air or oxygen dissolved in blood is slightly more than atmospheric pressure. But at a greater depth, pressure is equal to what? Pressure due to atmosphere plus pressure due to depth. So at a greater depth, pressure increases. And pressure increases, it becomes more than that of atmospheric pressure. Atmospheric pressure is the pressure becomes very large in comparison to atmospheric pressure. And you know, in our body, what is the pressure of the blood or pressure of the oxygen dissolved in blood is almost equal to atmospheric pressure. So pressure of blood in the body is less, but the pressure of water outside is more. Outside pressure is more, inside the body of the human being pressure is lesser. So therefore human body will collapse. Human body will collapse. Okay, it will be squeezed. So therefore person will die. Right? Just to protect his body from collapsing, the person is wearing protective suit. And this protective suit is designed in such a way that it protects the body from the pressure of the water. Right? Pressure of the water is compensated by the suit only, and the body inside is protected from that high pressure. Clear? So this is the reason.